Okay, so let's have a look at the Leaving Cert Higher Level Maths Paper 2, 2022, and this is question 10. In an athletics competition, there were a number of heats of the 1500 meter race. In the heats, the time that it took the runners to complete the 1500 meters were approximately normally distributed, with a mean of 225 seconds and a standard deviation of 12 seconds. Find the percentage of runners in these heats who took more than 240 seconds to run the 1500 meters. Okay, so if you take the actual times, the mean was 225, and then we had a standard deviation of 12 seconds. So 240 then is going to be up around here somewhere, 25, 35, 45. So let's say about here. So this is going to be your 240 seconds. So we want to know the percentage of runners in the heats who took more than 240 seconds. So we want to know the percentage of runners who are in this part of the graph. So what we need to do really is just convert this 240 to a z-score and go from there. So we need to standardize, in other words, our graph here. So this would be 0 here, and we want to work out what this z-score here is going to be, which is equivalent to this region of the graph here. So let's do that then. We know that the mean is 225 seconds. The standard deviation from the mean is 12 seconds. So what we want is the probability of x, or x value, these are x values here, being greater than 240 seconds. So we got to convert that to a z value. So that's really the probability that z is going to be greater than. Now remember, our formula for z is x minus mu divided by standard deviation. So it's going to be x, which is 240, minus our mean, which is 225, divide that by the standard deviation, which is 12. So this is what we've got to work out. Now that's the probability that z is greater than, when you work that out, you get 1.25. So that's our z-score. That's this value here. Z is equal to 1.25. Now this is z is greater than, so the tables that you have will only allow you look up less than rather than greater than. This is positive, which is fine. Again, the tables will only allow you look up positive values. So what we want to do here is look up this area here and subtract from 1 to get this area up here. So it's going to be 1 minus the probability that z is less than 1.25. That's going to be equal to 1 minus 0.8944. So where did I get that 0.8944? So if we just have a look here, we want to look up a z value of 1.25. So we come down along here, we've got 1.2, and we have our 0.05 here. So that's this one here. So 1.2 and 5 is 0.8944. Okay, when you do that, 1 minus 0.8944 is 0.1056. So that's, what does it actually ask us for? Find the percentage. So our answer then, our answer is 10.56%. Okay, so let's have a look at the next part of the question. Okay, so the 20% of the runners with the fastest times qualify for the final. Assuming the race times were normally distributed as described above, work out the time needed to qualify for the final, correct to the nearest second. Okay, so if we just look at our graphs again, so we have our normal distribution here. The mean here was 225 seconds, and it's going to be the top 20% with the fastest times are going to qualify. So the fastest times are going to be down here. So this is going to be 20% of the runners are going to be in this particular area, which means that 80% of the runners are going to be up here. Okay, so we've got to work out what this x is here, what time this is going to be here. So how do we do that? Okay, so we can't look up greater than and we can't look up negative values. This is going to be a negative value down here when we convert it to a z value. So what we got to do is just flip that up around here. So our 225 is going to be here. We're going to put the x value up here. This is going to be 20% of the data here. This is going to be 80% here. So it's going to be the same kind of thing. So you've got to work out this x value here. Our standard normal curve is going to be the same kind of thing. This time we have 0 here. We're going to look for this particular z value here. 20% of the data is going to be here and 80% here. We really just have to work out what this z value is by looking at this 80%, because remember again our tables will only apply to positive z values and less than that particular z value. So let's look at 80% or 0.8 on our tables. So the nearest one we can find here is 0.7995. What z value does that give us? Well, it's 0.8, and then if we look up here we've got 0.04, so it's 0.84. So this z value here is going to be 0.84, and because of symmetry here, this z value down the other side is going to be minus 0.84, which is really what we're looking for. We need to look at this part of the graph here. This part of the graph here, which in terms of the standard normal curve is going to be down here. So this is where 20% of the runners will be. So our z value is actually minus 0.84. Okay, so how would we work out that particular z value then? Okay, so what we do is we take our x value, which we've got to work out, and then we've got to subtract the mean, which was 225. You've got to divide by the standard deviation, which was 12, and we know now that that's going to be equal to minus 0.84, this value here. Okay, so all we've got to do now is multiply across by 12 and then add 225. That'll give us an x value then of 214.92 seconds. This is the time where anyone who reaches this time will qualify for the final. So it's anyone less than this, anyone who reaches a time less than this particular time here. Now we've got to do this to the nearest second, so our answer can't be more than this, so it has to be less. So our answer is 214 seconds. Okay, and that's it. Sally takes part in a number of different races in the competition. The probability that she makes a false start in any given race is 5%. Find the probability that she makes her first false start in her fourth race. Give your answer correct to 4 decimal places. Okay, so this is a Bernoulli trial of sorts. It's what we call an extended Bernoulli trial. So what we're going to do here really is just look at the first 3 and then the fourth one separately. So let's have a look at the first 3 races. It's going to be 3, choose 0. So this is where she has no false start, and that's going to be 0.05 to the power of 0, 0.95 to the power of 3 minus 0, which is 3. So this is the probability that she has no false starts in the first 3 races, and then her first false start in the fourth race, so we just multiply by 0.05. So this is the first 3 races, and this is the fourth race. So she has no false starts here, and then she has her first false start in the fourth race. So when we do that, you just multiply all that out and do all the calculator work. You get 0.0429 to 4 decimal places. Okay, so that's it for part B. Let's have a look at part C then. 20 relay teams took part in the competition. For any particular team, the probability they drop the baton at some point during the competition is 0.1. Find the probability that at most 2 teams drop the baton during the competition. Give your answer correct to 4 decimal places. Okay, so let's start that one. So the probability of dropping the baton is 0.1. Now it's at most 2 of the teams, so we're going to do the probability that none of the teams drop the baton plus the probability that 1 of the teams drop the baton plus the probability that 2 of the teams drop the baton. We're going to add those 3 basically. So we're going to do 20, choose 0, so this is the probability that none of them drop the baton, so that's the power of 0, and then 0.9, or 20 minus 0, which is 20, plus the probability that 1 team drops the baton is going to be 20, choose 1, again 0.1, 0.1 to the power of 1, and then it's 0.9 to the power of 20 minus 1, which is 19, and then 2 teams drop the baton, that's going to be 20, choose 2, and then 0.1 to the power of 2, 0.9 then to the power of 20 minus 2, which is 18. Okay, so this is the probability that no teams, 1 team, and then 2 teams drop the baton. We just add the 3. So okay, when you do all of that then, you get 0.12, let's see, we'll do them individually, 0.1215, 7665, 46 plus 0.27017, 03435, 03435 plus, and then the last one is 0.285, 0.28517, 9807. Just got to add those 3 up and you get this to 4 decimal places, so it's 0.6769. 0.6769 to 4 decimal places. Okay, so that's part C, so let's have a look at part D then. 300 runners take part in a road race. Each runner has a number from 1 to 300. No 2 runners have the same number. 2 runners are picked at random from the runners in the race. Work out the probability that the sum of their numbers is 101. Okay, give your answer as a fraction in its simplest form. For 2 runners to be picked at random and for their numbers to add up to 101, you've got to look at all the different possibilities. So let's say the first runner is picked and they have number 100. The other one then must have number 1. The other next possibility would be 99, 2. Next one would be 98, 3, and so on, all the way up to 100. Okay, so these are all the different possibilities where the 2 numbers add up to 101. So how many of these are there? There are 100 of these. From 100 down to 1, that's going to be 100 possibilities. So let's just have a look at the first one. The probability of picking someone at random and for them to have the number 100 is going to be 1 out of 300. And you got to multiply the second runner that you pick at random, for them to have the number 1 is going to be 1 out of 299 because you've already picked the first person here. So that's the first one. Second one, to pick someone at random and for them to have the number 99, it's going to be 1 out of 300 multiplied by, and for the second person to have the number 2, that's going to be 1 out of 299. So you can probably see what's going to happen here. It's the same all the way out here. You got 1 over 300 times 1 over 299. So you got to really do this 100 times. So when you do that, in other words, you got to do one of these and just multiply it by 100. When you do all of that, you get in its simplest form anyway as a fraction is 1 over 897. And that's it. Give your answer as a fraction in its simplest form. So that's it. Okay, so let's have a look at the last part then, part E. Okay, so a lot of reading here. Let's have a look. Circa ran 2 different marathons, the windy marathon and the sunny marathon. The table below gives some details on the finishing times for the 2 marathons. For each marathon, the finishing time of the runners were approximately normally distributed. Circa's position in each marathon was based on her finishing time. Circa came 5,265th in the windy marathon, so that's here. That has a mean of 254, standard deviation of 39, and the number of runners 6,000. Okay, so let's see. Circa came, so they did all of that. Circa's finishing time for both marathons was the same. Using this fact and the details in the table to estimate Circa's position in the sunny marathon, show all of your working out. Okay, so we got to work out this position here, Circa's position in the sunny marathon. Okay, so let's have a look then. We're going to look at the windy marathon first, let's say. So the windy marathon. Okay, so again here the mean, we're given all this information, but the mean is 254 minutes and the standard deviation is 38. Okay, so if Circa in this particular race, the windy marathon, came 5,265th, that means there were 5,264 runners who finished faster than her. So really what we're looking at here is the mean here. Well, that's the mean finishing time, but if we look at the position, let's say 254 here, but if we look at her finishing somewhere around here, what we've got to do is work out the percentage of runners who actually finished before her. In other words, those who had quicker times than her. So the number of runners who finished before her were 5,264. There were 6,000 runners. Multiply that by 100. That gives you 87.73. 87.73 repeated. We'll just go to 2 decimal places here, percent. So that means that there were 87.73% in this part of the graph who finished faster than Circa. So let's have a look at that then. Okay, we want to work out this time here. If we look at the standardized graph, really what we're doing is taking a 0 here. We're looking for this Z value here. We know that this is going to be 0.8773 down here, or 87.73% of the runners are going to be in this part of the graph here. So we got to work out what this Z value is. So I'm going to look this up in the tables again, 0.8773. So if we just go back to our tables and look for 0.8773. So we have a 0.8770 here. The next one is 0.8790. So I'm going to use this one here, 0.8770. So what Z value will that give us? Well, it's 1.1. And then if we go up along here, so it's going to be 1.16. So that particular probability here is going to be 1.16 in terms of Z value. This Z value here is 1.16. Again, how would we work out that Z value? Well, we would take a certain time. We would subtract the mean, which is 254. We would divide by the standard deviation, which is 38. And that should give us our 1.16. So we can work out the time it took her to run the windy marathon, which is x, by just solving this equation here. So let's see, we've got to multiply by 38 and then add 254. That'll give me an x value of 298.08. I think this is probably minutes, is it? 08. This is going to be minutes. So that's the time it took Circa to run the Windy Marathon. So we have our time here now, which is 298.08 minutes. Okay, so we know that she finished, I think it said in the question that Circa's finishing time for both marathons was the same. So let's have a look at the Sunny Marathon now. So we now know her finishing time for this marathon. So we know the X value, if you like, is equal to 298.08 minutes. Okay, so this time there were 2,000 runners. The mean time was 247, and with a standard deviation of 29. So this time the mean is equal to 247 minutes, and the standard deviation is 29 minutes. We have everything we need then to work out her place then in this case, her place. So let's do that. So we have our Z value is equal to 298.08 minus the mean of 247 divided by standard deviation 29. That gives us a Z value of 1.76, 137, and so on. So this is our Z value. So again, if we have our standard normal distribution here, the Z value is going to be up around here. Z is equal to 1.76, let's say. Okay, so we've got to work out then her position. So the first thing we're going to do here is just work out the percentage of people down around here. So all we've got to do is look up this value, 1.76, in our tables. That'll give us the percentage of people, or the probability of finding someone who appears in this part of the table here. So when you look up 1.76 again, let's have a look at that. 1.7 is here, and then I think it's going to be here. Let's have a look. 1.7, oh, that's 0.75, it's the next one out. 1.76 is 0.9608. So the probability that someone finished faster than her in this particular marathon is 96.08%. So the probability, in other words, I'll write it out, the probability of Z being less than 1.76 is equal to 0.9608. That means that 96.08% of runners finished faster. So we had how many runners? 2,000 runners. So all we've got to do is get 96.08% of 2,000, and that equals 1921. So that's the number of runners who finished faster than Circa in this particular marathon. So that means the answer then, she must have finished in 1922. Second place, so 1922nd place. I think that's all we were asked for here. Let's have a look. Use the fact to estimate Circa's position. Use this fact and the details in the table to estimate Circa's position in the Sunny Marathon. Okay, so show all your workings out. So we've done all of that. So her position was 1922nd. Okay, and that's it for this particular question.